gonna, 12 is made up of 10 and then 2, so I'm gonna write the 1 denoting the 10 first, and then I'm gonna write the 2. If I were doing it in a little endian format, I would have written the 2 first, and then I'd have written the 1 first, because then I'll read it from left to right, so, or I'd have read it from right to left. So when I store something in a little endian format, in this case, since I'm using 16 bits, which is 2 bytes, what is important is that the lower order bits are going to be stored first, and then the higher order bits are going to get stored, which means when we retrieve these values, when we retrieve the depth values, we have to flip it back. Does that make sense? Otherwise, you will not get the right number. You have to flip it back and then read the whole value, which we'll look at in the demo. So this is just an example. This is just a slide that illustrates little endian format. So that's basically all I wanted to talk about depth in the slide. So it basically still returned as imageframe.image.bits, and it starts at top left just as before. It moves from left to right and top to bottom just as before, but instead of representing RGB values per pixel, it is now representing distance values per pixel. Does that make sense? Okay, so let's go in and do the demo. So I'm going to come in, I have this exact same code as before, and I'm just going to modify this to, instead of just doing color values, so now it does depth values as well. So which means instead of just reading the RGB camera, now I'm going to read the depth camera as well, which is actually the more interesting part of the game. So the first line that I wrote earlier about initializing or instantiating my OneConnect still is going to remain the same, right? Nothing really changes here. The next line, where I initialize the connect, is going to change a little bit. Instead of just saying use color alone, now I'm going to use the OR sign and chain another option of saying either use depth or use depth in player index. First of all, I'm just going to say use depth. Let's just use depth first and see what happens. Then we'll come back to depth and player index. This one line now, what it's now doing is it's initializing the driver subsystems, the software subsystems for both the RGB camera now through the use of use color, and also the depth camera through the use of use depth. Right? So now both subsystems, the entire camera subsystem in the Connect will get activated. The next line was where I was opening the video stream, right? So now what I would do is, apart from just opening the video stream, I would open the depth stream as well, because again, remember, the depth stream is the feed from the depth camera. So I'm going to open it, and most of the options are going to be very similar to what we saw earlier, except now instead of image stream type.video, I'm going to choose image stream type.depth. And then instead of, actually the pool size was 2, and I think 2 is still a good pool size to go with. And instead of a resolution of 640 by 480, a resolution of 320 by 240, since that's the default. And finally, image type is going to be image type dot. Instead of color or color by UV or color raw, I think it's going to be dot depth, because we're pulling depth data. But you see how similar the code is, right? This line and the previous line are super similar. You're just changing 2 values. Instead of dot video, you get dot depth, and again, instead of dot color, you get dot depth. That's it. Everything else, and the resolution you end up changing, because the default resolutions are different. And once you do that, that's it. Then the next thing we did was basically create a new event handler for video frame ready. Now I'm going to create a new event handler for depth frame ready. Right? I'm just going to say plus equals tab gives me a new event handler, and I'm going to empty it out and start coding. Now you see, like before, I can do exactly the same thing. In fact, this line I can take and just copy as it is, because E right here will still send me an image frame, right? And image frame dot image will still have the actual data. So you know what? Let me do this. I see image is of type planar image. On the left, you can see that it's planar image frame.image. So I'm gonna store it in something of type planar image. Planar image p image equals iframe.image, right? I've grabbed the image. But here's the thing. I probably, see in the previous case, since all of the data that was coming in my image was just RGB, I could just take it and throw it directly into an image source. In fact, you know what? Let me show you something. Let me just copy this and paste it here. Let's see what happens. Instead of image1.source, I'm going to say image2.source, but let's make sure there's an image2 here. I'm going to come in here, drop another image. Where's image? There it is. Okay, I have this other image. So this right here is image2, right? If you look at the source code, here's image2, right? So this is image2. So I now can say image2.source equals bitmap source.create iframe.image.width. Well, iframe.image is p-image, so I'm just going to use p-image instead of iframe.image. So p-image.width, p-image.height, 9696 will be the same. Pixel formats, PGR32. We'll come back to that in a second. The stride is still going to be p-image or the data is still going to be in p-image.width, and the stride is still going to be p-image.width times p-image dot bytes per pixel. Right, so this is exactly the same as before, in fact. So here's my problem now. My only problem is I know that the data that's coming back is still in bits. Everything is fine, but the data in bits, each data segment now isn't 4 bytes long. It's not a BGR. It's 2 bytes long. It's a 16-bit structure, right? You saw that, right? And here's the problem. If I run this the way it is, let's just run it and see what happens. If I run this the way it is, you see how there's an exception? It says value does not fall within the expected range because it's expecting a 4-byte structure, and then it's reading 444 bytes at a time, but then it finds out that halfway across it just terminates because it's for the entire length it's supposed to be 2 bytes long, but now it's reading 4 bytes long, and so it's halfway through the process it finds that the array is empty, and so it basically says value does not fall within the expected. So it's freaking out, right? So let's look to see if there's some 16-bit values in here, right? So all of these this is a 24-bit value, this is a 32-bit value. Let's keep coming down. There's actually something called gray 16, which is a 16-bit value, right? So let's try and see if we can run it now. And you'll find that you can actually run it. I mean, it is actually running, and you'll see that it's actually displaying some data. In fact, if I move my hand, are you able to see it's doing something? Like if you look at this window in this region, I can see some movement, but it's all so dark that you can't really make anything out, right? And you know why that is? So the gray 16 scheme is used to denote brightness values across 2 bytes, across 16 bits, right? The brightness values it expects are a number between 0 and 64K, that's 2 power 16, right? You know how RGB, each channel expects a number between 0 and 255, because it's 8 bits. Similarly, gray 16 expects a gray or a brightness channel, or not a brightness channel, a grayscale channel between 0 and 64K, 65,555, right? Now here's the problem. The data that it is trying to encode is right here, right? The problem with the data it's trying to encode is that the data is only 12 bits long, right? The depth value is only 12 bits long, which basically means that the maximum number that can be stored in the bits field is 2 power 12, which is 4096, right? So what we are doing is we are showing an image where the maximum ceiling limit is only 4096. And imagine doing that in a gray 16 format where 64K is white, full white, 65,585 is full white, and 0 is full black. Now, if your ceiling is only 4,000, if all the values you supply are topping out at 4,000, 4,000 is still significantly smaller than 64,000, and so most of the image appears dark. Does that make sense? Right? Which is what's happening here. You'll actually be surprised. There's actually valid data here. It's just all appearing dark is what it is. Now, the fact of the matter is, though, that instead of trying to display raw data like this, and most of it appearing dark, if you want to represent this data in an image, you have to do one of two things. One, let's take this and amplify it enough to store it to make sense in a 16-bit structure, like Ray 16. Or number two, let's come up with our own heuristic, right? Instead of displaying it as it is, let's create a new byte array and code it with RGB values based on distances. So let me explain what I mean by that. But before that, let me show you the data that's in p-image. You know how we saw the data that was in iframe? We saw the values where, RG or BGR and blank, BGR and blank. Let's actually see what's in p-image before we proceed any further. So let me set a breakpoint here. Let me run this. And you actually see we hit the breakpoint. Now let's examine p-image. P-image, as before, is just a long array of bytes. Now, except this time, it's 153,600 long. Let's find out what is the significance of 153,600. 153,600 is just 320 times 240, which is the resolution of the image, times 2 bytes per pixel. Is 153,600. Does it make sense? Okay. Now, that is the 153,600, which is this. Bytes per pixel, as you can see, is 2. Height and width are 320 by 240. If you look at the data, though, you'll find that, well, it's all turning out to be 0 because I think, okay, here's the thing I also want to mention. Kinect, like we said, can only detect between 850 millimeters and 4,000 millimeters, right? Any distance under 850 or any distance over 4,000 gets represented as a 0, right? So if the Kinect's here and the extreme corner that it's looking at is too far out for it to make sense, then it's going to show it as a 0, right? And that's what you're seeing. In fact, it's very common to run a program and see a huge bunch of zeros before you see anything meaningful, because this means that the top 2 or 3 rows in that image are all either too far out or too close in. And so when I do a demo like this in an audience like this, where the top rows are sort of here, you're going to see all zeros because Kinect cannot see anything within 4 meters. So if you keep going, you might have to wait a little bit actually. Yeah, this is going to take it, because right now it's sort of processing. And remember, each row is 320 bits long, or 320 pixels long, and each pixel takes 2 bits. So each row has 640 array elements, so which means we're still in the second row of pixels, right? So as you can imagine, there's quite a long way to go before we'll see any data. But when the data does show up at some time halfway through the image, you know what, let's actually do this. Instead of doing this, let me turn it towards myself. Let me just show my hand about a meter away so it actually sees something early on. Or let me just stand like this, it'll see only me. And now let me run it again. Okay. And now, if I look at iframe, open this, not iframe, p-image, open this. You see how early on there's data? So, so that was a good use of time instead of waiting for it to scroll through, right? Okay. So here's the interesting part, right? You'll actually see that the values here, you'll actually see proof of being little endian, right? So obviously because the fact of the matter is that you have a 12-bit structure. If it were big endian, the first byte would have had 4 bits, and the next byte would have had all 8 bits, right? 4 plus 8 bits. But because it's little endian, it's flipped. So the first byte will have full 4 bits, and the next byte will only have, or the first byte will have full 8 bits, the next byte will only have full 4 bits, right? Or the remaining 4 bits. Which means the first byte can range between 0 and 255, but the next byte can only range between 0 and 2 bar 4, which is 16 or 32. 2, 4, 8, 16, yeah. So you'll actually see that the first byte, every even byte, 0, 2, 4, and so on, will range between 0 and 255. The next byte, 135, will only be between 0 and 16. So you can see that over here. But this gives you a general idea of the data that's coming back. Again, these are not color values, these are not grayscale values, these are raw distances between connect and what is seen. So I think what makes sense to do is, instead of trying to render this directly into a color image, let's actually try and do something else. Let's try and do a small computation called, say, calculate distance or something, where we pass it p_image.bits. Right, so what I'm doing is I'm taking the whole array and passing it into this method called calculate distance, which doesn't exist. So Visual Studio says that I can generate this, which the stuff for it is generated here, so I can come in and start working on it. Now, let's identify the approach we want to take. The depth frame, since it returns distances, let's basically do it this way. You know how I deleted this code block here that was actually showing a bunch of... Okay. You see this code block here? It actually displays an image, right? But instead of gray 16, let me just do BGR32 like before. But instead of p_image.bits, let me leave it blank for now. But what I want to do is this. Like before, I want to display a color image, but this time I will create my own color image, right? Based on the distance value, let's generate a depth histogram, if you will, and display it on the screen. So let's come back and revisit this code section after we are done with the computing distance aspect of things. So what I'm going to do now is I'm going to take the data that gets returned, just distance images, and calculate the distance for each pixel on the image. So I'm going to do something like this. I'm going to run a loop for int I equals 0, I less than p_image dot bytes, dot bits dot length, right? This basically is going to run through the distance of the array, and I'm going to have it skip by 2. So what I'm going to do is I'm going to grab every alternate byte. Now the next thing I'm going to do is I'm going to call a method called getDistance, which is what we did before. But now I'm going to pass p_image.bits of I and p_image.bits of I plus 1. So what I'm doing is basically I'm passing it the successive 2 bits, which means for each pixel I'm sending it the 2 bits that represent that distance. Now in my getDistance method, what I need to do, this is my getDistance method. It's taking byte p. I'm going to change it to call it byte p1 and p2. In getDistance, what it's getting is it's getting 2 bytes. What I need to do is, since it's stored in a little endian format, I have to flip the order and read the value back. So I'm going to write the source for it, and we'll talk about it in a second. I have bytes p1 and p2. I have to basically combine them together. The way I would combine, how would you combine 2 bytes together? You would use an OR, right? So if these were stored in big endian, I'd have done this, P1 or P2, right? It's basically, you know, the order is fine, P1's first and then P2's. But because this is stored in a little endian, I want to take P2 and put it ahead of P1. And the way you put something ahead is by left shifting. Yeah, exactly. So let me shift this by 8 to move this one full byte ahead, and then let's combine it. And funnily enough, let's see if this combines. Okay, it needs a semicolon. What is that? Here. Okay, build actually succeeded. So now, this one line right here basically takes 2 bytes, are stored in a little endian format, makes the second byte get in front of the first bit, adds them together, and gets the distance back. And let's actually, at this point, return distance, which let's collect here. Int distance equals whatever. And you know what, let me just type some random line of code here, set a breakpoint here, or not breakpoint there, a breakpoint in the next line, and then let's compute distances. Okay, what's the build error? Okay, it's because I've already used I up here. I'll call this J instead. Okay, can I just remove void? Okay, here's the problem. I'm returning a void. I should say int. Okay, I'm on now. Great, it works. So let's set the breakpoint here. Let's run this. Let me stand before the connect. And now, for I is 0, which means for the first pixel on the top left, right? It's returning the distance as 2,505, which is this what to? It's I think seeing me or somebody. I think it's seeing this, and this distance is about 2.5 meters. Would you agree? Yeah. So you basically see that our computation seems like it is working. So if I keep running, let's keep, see 25, 23, and then as it keeps reading the frame, it will come to me, and sometime soon the distance will actually reduce 2,542, whatever. So you'll basically, we're seeing that the code actually kind of seems like it's working. So the distance we're gonna get is gonna range between 850 and 4,000 ideally. So let's do this. Based on the distance value that we get, let's create a new byte array filled with RGB values and display it on the screen. I'm going to write 4 or 5 lines of code first, and then we will examine it in a second. Because I'm really bad at writing code and talking at the same time. So I'm going to say int color index 0. BGR, blue, green, red, okay. Offset. Okay, so BGR, and now what I'm going to do is let's create a new array, byte array color equals new byte array of I think it's going to be p image width times image.height. I'll explain this in just a second. What is this one? Oh, okay. So it should have. Okay, how do you create a new byte array? Basic C#. Anybody here that's done C#, how do you create a new byte array? Okay, sorry?
Just add a new byte step to the number.
Right, this should work, right? Any creation, okay, there we go. And then my dimension should come here. Perfect, thank you. Okay, so here's my new byte array year long, and what I'm going to do is come in here and let's start populating this array based on distance. So I'm going to run a series of if statements, if distance, and we happen to know that the value out of range is going to be 0, so I'm going to say something like this. Let's sort of break down the distance into how about from 800 to 2000, 2000 to 3000, and 3000 to 4000. So which basically means, let's break it down as if distance less than 2000, do something else. If distance less than 3000, do something. If distance less than 4000, then do something. Actually, I'm going to have an if statement to handle the 0 condition. Distance less than 800, do something. Or 8,800. So this is the situation where out of range.